The curve C has equation 9x squared minus y squared plus 3xy minus 5 equals 0. Okay, you're asked to find dy dx in terms of x and y. Hence, explain why C has no turning point. And two, there are two parts. The other part is find the equation of the tangent and the normal to this curve at the point 1, x is 1, y is minus 1. So before we do anything, we may need to tidy up this equation to find dy dx. Okay, dy dx, of course, is so-called the gradient, or so-called the slope of the at this point, okay, at the turning point. But of course, the question says there's no turning point, so we'll see why there's no turning point. So look at this given equation. So we may want to make y the subject. Okay, try to make y the subject, but seems like it's not possible to make y the subject because the equation looks a bit complex. So in this case, we will have to use a implicit differentiation. Okay, differentiate both sides by respect to x. Okay, differentiate the left hand side and the right hand side respect to x, and try to get the term dy dx. So I differentiate both sides with respect to x, just a big bracket, and then remove the bracket, expand it. Okay, so we have differentiate 9x squared, differentiate y squared, 3xy, and 5. And of course, differentiate 0 is 0. Okay, so differentiate 9x squared is quite straightforward. 9x squared will be 18. Bring down the 2, power 2, and then the power is 2 minus 1. 2 minus 1 become 1. Okay, because differentiate y is equals to xn, so dy dx will be equals to n x n minus 1. Okay. So this part will be 2 times 9, 18, 18 times x. Okay, and okay, we can't differentiate y with respect to x. So what we can do is, we want to multiply a term dy dy. Let's we always bear in mind that we are not allowed to change the original expressions. Okay, so multiply dy dy is still 1. Okay, dy dy, anything times 1 is still anything. Okay, so dy dy, and then this part, we may want to use a product rule. Okay, say product rule, let this be u, this be v. So v du dx and v du dx and u dv dx, and differentiate constant is 0. Okay, so this part, okay, now come to this. We swap the denominator. Okay, we can swap the denominator, or you can swap this, the top, because it's multiplication. So you bring the dy here and dy squared here. Okay, so I'll have dy dx, and this part will be dy squared dx. And this part is just tidy up. Differentiate 3x is 3. So 3 times y. Okay, and 3x dy dx, since we are after dy dx, so we just leave it. Don't do anything to this one, just take it dy dx. And the next part, again, tidy up the maths. Dy squared respect to y, so differentiate y squared respect to y will be 2y. It's like differentiate x squared respect to x is 2x. Okay, so this one will be 2y, and then we keep this dy dx since we are after dy dx. Okay, and then collect the like terms. So there are two sets of terms with dy dx. So we just put them together. So 3x and minus 2y. And then move the other terms to your right hand side. So we are nearly getting the dy dx. So this is the answer for dy dx. Okay. But so this answer for dy dx part of part 1. Okay, but we are asked to find a turning point, and then we are told that there's no turning point. Turning point means something like this at this turning point. Why there's no turning point? Okay, not all the graph have a turning point like a U shape. Okay, not all the graph have this turning point. So it say it does not have a turning point. So we'll check. Turning point means the gradient, the slope will be a slope of, if you draw a tangent, the slope is equals to 0. That means dy dx equals to 0. So we let dy dx equals 0 and try to find the x and y. See whether we can get x and y or not. If there's a turning point, we can get x and y. If there's no turning point, we can't get the answer for x and y. So dy dx equals 0. So we have found dy dx, and then turning point, this term will be equals to 0. So just tidy up the maths. Okay, cross multiplication, we get y equals to minus 6x. Okay, y equals to minus 6x. So when y is equals to minus 6x, what is my x? What is my x? So, the given equation is this, the given curve. So if we know the value of y is minus 6x, so can we find x from this equation? So you just substitute minus 6x to the y, minus 6x to the y, and then try to get the answer for x. And then we ended up the x is a square root of minus 1/9. So it's not possible because x and y are it's a real number, so it cannot be a negative square root. And of course, x squared, any thing that to a power squared, the answer should be positive. At least the answer minimum should be 0. But here is not 0, and it's a square root negative. Okay, when you find the x is a square root negative, x squared is a negative, so is something not quite right over here. So since it's something not correct, that means we can't get the x. If we can't get the x, that means there's no turning point. Okay, because we can't find a point that make dy dx equals 0. Okay, so there's no way that we can get dy dx equals 0. So there's no turning point. So it's not possible. So therefore, the curve has no turning point. Okay. So that is part 1. Part 2, we are asked to find two equation of the tangent at point 1 and minus 1. That means x is 1, y is minus 1. And equation of a normal, equation of a tangent at this point, equation of the normal at this point. Okay, tangent is like, for example, at this point, 1 and minus 1. Okay, I want to find a tangent line. This is so called a tangent. Okay, equation of a tangent. And then normal will be perpendicular to the tangent. Normal will be perpendicular to this tangent. So this line will be so-called normal line. And this line, the line that is tangent to the curve, is called tangent line. And then perpendicular to this tangent line is called normal line. Okay. So of course, to find an equation of a straight line, you always think of equation of a straight line is like something in this format: y equals to mx plus c. Okay, y equals to mx plus c. So we need to find the m. Okay, so we know that the formula for gradient m is the dy dx is the gradient, is this formula, the difference between y and x, y minus y1, the difference between two y point, and the difference between two x points. Okay, so we know that we have found dy dx is, this is dy dx that we have found just now. So at 1 and minus 1, what is my dy dx? You just replace x and y by 1 and minus 1. And we have found that dy dx is minus 3. So now we have the gradient. We can make use of a formula, this formula, to find the line of the equation. So substitute, again, make use of this, and then we want to find the equation to be y in terms of x. And then we have already know from here the m, this is the m is minus 3. So minus 3, and then y minus, the p point is y is minus 1, x is 1. And then just tidy up this and then put into an equation. Okay, so this is how we get the equation of the tangent. Okay, normal would be, this is the gradient of the tangent. So normal, remember, normal would be minus 1 over m2. Okay, or if you still remember, the normal and the tangent, the gradient of the normal and the tangent, if you multiply the two gradients, it should be equals to minus 1. So we know that if the gradient of the tangent is minus 3, so gradient of the normal will be what? Minus 1 over minus 3 will be 1/3. So this is for the tangent. So normal will be minus 1 over the tangent, the gradient. So minus 1 over minus 3. Okay, m1, if you remember this formula, m1 equals to minus 1 over m2. So if this is the tangent gradient, and if this is the normal gradient, say this is a normal gradient. So we found that it's 1/3. Again, we make use of this so-called equation of the line. Okay, so 1/3 equals to y and x, because equation of the line, we want it to be in terms of x and y. So y and x, and at this point, 1 and minus 1, 1 and minus 1. Okay, so the subsequent step is just tidy up the maths to get y in terms of x. So that is the equation for the normal. So that is the answer to the question.